Hi, in today's tutorial we are going to classify vehicles to 5 categories. However, it will not be let's say a straightforward CNN process. It will be a combination of the VGG16 and XGBoost. So it will be a very interesting tutorial. So first of all, let's start with downloading the dataset. You can find it in Kaggle. It's a standard dataset that is composed of several folders: train, test, and validation. And for each folders, you can find the images. This, for example, is the bus images. So we will download this dataset, copy it to a local folder, and here you can see all the images. For example, we have under a car folder, we have all the car images. Let's zoom a little bit for several images. As you can see, these are several car images. Let's go to another folder. For example, these are train images. So let's jump directly to the coding part. The process will be divided to 4 steps, and the first part will be preparing the dataset. We will start with import the essential Python libraries, and these libraries provide functions for working with data, images, and machine learning. As you can see, I'm leaving some comments for the relevant pip install commands. We will use in Tensorflow, we will use in XGBoost, OpenCV, and NumPy. So this is the link for the dataset. You can download the dataset and put it on your local folder. And now we begin with the import the relevant Python libraries. And first of all, let's see and navigate through our dataset. So let's copy the full directory path. If you're using Windows, don't forget to change the slashes to the right direction. Okay, let's run it. As you can see, we have 3 folders: test, train, and validation. So next we set the variable size to 256, indicating the desired image size. And next we will create a new list, one for the train and one for the images, one for the labels. And we will use a loop to go through each subdirectory in the train directory and extract the category label. Okay, let's write this code and print it. We extracted it from the full path of the folder. Let's run it and you can see the result. As you can see, these are the 5 categories. Now let's write another loop through each of those folders and grab the name of the files. And as for now, let's just print it just to double check that we have the full path for each image. So let's run it. Okay. So next we read and process each image. As you can see, we are reading or importing the content of each image file. We resize it to our required dimension. And after we process the image, we append the image and its label to the respective lists. After looping through the folders, we are converting each of those lists to a NumPy array. And we will print the shape of each of those NumPy array just to double check the amount of the amount of total images, and basically see that we have a perfect shape of images and 256 by 256, and of course the corresponding labels. So let's run it. You can see that we have warning images. You can ignore it, it's okay. As you can see, we have more than 5,000 images, and we finished the process for the training data, and now we will do a similar process for the validation data. Let's run it again. And let's see how many validation images we have. We have more than 700 validation data. So now we are ready to save those NumPy array to our local folder. And we use the np.save to save the training and the validation data in the NumPy array. We specify the file path, and we also add in some printing commands for the starting point and ending point. And that, I believe, will be the end of part number 1. Okay, let's run it. Saving. Okay, finished. Let's see. We are expecting to see 4 files. These are the 4 NumPy arrays. Great. Let's continue to part number 2. Okay, now let's start part number 2. In part number 2, we will extract the features using a VGG model. So basically, we will load our saved data. We will do some encoding to the labels to transform them from text to integer value. And we'll also prepare the data and normalize it for the model. Then we will plan to load the VGG model, but we will not going to train the data. Instead, we will extract the features from the last layer of VGG16 and reshape it for the next process, which is the XGBoost. So basically, as you can see, the first step is loading our saved data, and we will store it on a new NumPy array for the train and for the validation. Then let's print the shapes of the loaded training and validation data just to confirm that they match our expectations. Let's run it. Okay, the data seems okay. The next step will be encode the labels. We would like to change the labels from text, like car, train, bus. We would like to change them to integers. So basically we will have 0 to 4 values. So in order to do that, we will use the LabelEncoder from scikit-learn library. And this will help us to transform the text labels into integers. And we will use the function trained LabelEncode to do this process. And this will make the integer as representation of the labels. So let's print before and after the labels. As you can see, before we get bus, 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 track, and after we have 0, 0, 0, and 4. Okay? So let's continue for the next step. We have to do the same thing for the validation labels. So we just copy and paste and rename the name of the variables. Also, let's print before and after. As you can see, we have from bus and track to 0 until 4. Okay. Now let's store these 4 unique categories. So we will use, let's say, an out-of-the-box value from the function. So we will use the .classes underscore attribute of the LabelEncoder to obtain the unique labels. The result will be stored in the original labels variable, and we will convert it to NumPy array. And you can see that we got these 4 labels. Okay, let's the next phase is just rename this NumPy array to a more straightforward names like Xtrain, Ytrain. So let's do this process. It will be just more convenient for the next step. Okay, next we would like to normalize the data. I mean the images. The images have values between 0 and 255, and for the model we need the values between 0 and 1. Please notice that I have a syntax error here that I'll fix it later. It should be xtest and not text. So when you are typing it, please notice and fix it. I already fixed it in my GitHub repo. Okay, next, now we are starting to load the VGG model. We load the VGG model from the Keras library. We specified that we don't want the last layer, the fully connected layer, and we set the input shape to our required dimension, which is 256 by 256 by 3, which is the RGB image. And of course, we need the original weights from the VGG model. So we loop through the layers in the VGG16 model and set each layer as a non-trainable by assigning false to the trainable attribute. So that's how we keep the original weights. Now let's print the summary of the model just to double check that we have all the layers. Yes, it seems okay. Please note the last layer, which is 8 by 8 by 512. So basically, after we will extract the features of the trained images, we're expecting to see the amount of images by 8 by 8 by 512. This will be an indication that we extract the features correctly. So now we are going to use the predict function, and after using the predict function with the trained images, we are going to print the outcome of the feature numpy array, and we are expecting to see, as I said earlier, the number of images by 8 by 8 by 512. So as you can see, we are running the predict method to obtain the feature extracted from the training images, and we will store it in the feature extractor. So let's run it and print the shape. Okay, I run it on a fast forward process, but after obtaining the feature maps from the VGG16, we will see the shape of those images, and we are planning to reshape it for a 2D format. That would be the next step. As you can see, we have 5418 by 8 by 8 by 512. Now we need to reshape it. The new shape should be the number of images by the rest of all the features. This will be a crucial step before feeding the data into the machine learning classifier. So we will use the reshape method to transform the feature extractor array into our desired shape, and then we will print once again the resulting shape for confirmation. Okay, let's code the reshaping. As I said earlier, we are reshaping the numpy array for the XGBoost. And after reshaping and printing the new shape, we're saving the extracted features as well as the corresponding labels for both the training and the validation set. And it will be important for the future when training the XGBoost classifier. So we use the standard numpy array save to save those array to a specific local file path. And this would be, I believe, the end of part number 2. Let's also save our model. Please notice the model was not trained, so we are saving basically the, let's say, the weights, the skeleton of the model with the weights that are included. And I believe that we also save the unique categories, which are the vehicles labels to a file. And this will help us mapping the labels prediction back to the corresponding classes. Let's run it. I'm going directly to the last phase, doing a fast forward. It's about 15-20 minutes, so let's go directly to the last phase. And we are expecting to see all those files in our local folder. Great. Okay, now we are going to use this saved data with the XGBoost. So we are going to create another Python file, the third one. And the first process would be loading the features and the white-rain. Please notice we are not loading the images, we are loading the extracted features and we are loading the labels. And let's print the shapes of those two NumPy array just to double check that everything is okay. Okay, the print statement indicates that it was completed correctly. Yes, it's okay. Okay, now we're using the XGBoost library to create an XGBoost classifier. XGBoost is, let's say, it's a powerful gradient boosting algorithm that is effective for various machine learning tasks. So we are importing the XGBoost and initialize the XGBoost classifier model. Then we will train the XGBoost model using the features extracted from the VGG16 and their corresponding labels. And this will allow our model to learn patterns in the data and make the predictions. So we use the Feit function method to train the model with our provided features and labels. Then we will save the trained XGBoost model so we can reuse it for making predictions on new data. Let's call it a 5 vehicle XGBoost.h5. And I believe this will be the last process of the third part. Okay, let's run it. So this process is about 2 hours of training. So I'm doing a fast forward and jumping directly to the end of the training. As you can see, the model was saved. This is our print statement from finish the training. And we are looking for the file. Here's the file. This file indicates our new XGBoost model. So now we are ready for testing our model. So let's create our fourth Python file, and this will be testing the model. May I remind you that we have a test folder with images and labels that our model never saw before. So we load, first of all, we load the test data from our saved NumPy array, and we will print the shape to indicate that it was loaded successfully. So let's copy from our previous Python file. We are loading the NumPy array with the full path, store it on new variables xtest and ytest, and let's print the shapes and see how many test images we have in our test dataset. Let's run it. As you can see, we have 709 images. So basically what we are going to do is take a random image and try to predict this image. So in order to do that, we first load in the save XGBoost model, which was trained in part number 3. This loaded model will be used for making prediction on our test data. It will be a random image. So we import the XGBoost, initialize the booster model, and load the trained XGBoost model using the function load model. Then we load the VGG model that was used to extract the features from the images in part 2. This will allow us to use the same feature extraction process for the test images. So we are importing Tensorflow and loading the VGG16 model for our stored file. And one more second, let's load it. As you can see, we are using the load model function and the path for our saved VGG model. Now we are using OpenCV. We select a random test image from our 709 test images. This image will be used, this random image will be used to demonstrate how our model makes a prediction. So we generate a random index n to select a random test image from the dataset and print in this index. Then we take the selected image, check its shape, and print it. For example, this was image number 94, and the shape is 256 by 256 by 3, which is a standard image. So now we will reshape our image. We will add another dimensions because it should be a batch of images. So basically we are expanding the dimensions. So in order to understand that, we will print the shape once again. After doing the expand dims, we're expecting to see 1 by 256 by 256 by 3. The 1 is indicate that this NumPy array has only one image on this batch of images. Okay, now we use the VGG16 model to extract the features from the selected image, this selected random image, and we reshape the features just as we did during the training. So we use the VGG16 model to extract features from selected image and reshape it for a 2D format. Okay, next. Now we prepare the input data for the XGBoost prediction by converting it into a D-matrix object. So this is a format that XGBoost required for making predictions. So we convert the input image features into this D-matrix object using the function D-matrix. And now we use the loaded XGBoost model to make a prediction on the selected image features, and the result would be a prediction for our image. As you can see, this is image 500, and we have 5 predictions, and the higher value should be the predicted category. So let's continue one more step and it will be more clear. So we will use the NumPy array argmax function. So this function looks for the higher value, and the output of the function will be the index of the value. So in this example, we have image number 253, and the higher value is index number 4. So let's see what is index number 4. Index number 4 indicate category number 4. So now we will use the original labels that we store earlier, and we will look for what is index number 4, index number 3, and get the text out from this NumPy array text. So we are expecting to see like a bus, a train, a boat, etc. So once again, let's run the prediction and for a random image, and let's see what is the text inside it. Okay, our random image is number 611, and it is motorcycle. Okay, this is index number 2, it is a motorcycle. So let's do another thing. Let's add the predicted label to the image and display it using OpenCV. So it allows us to visually see the model's prediction on the selected image. So we are using the put text, and I am shown to predict, to present the image, and let's run it again. And we got a train. As you can see, the label train. Let's run another one, and this is a bus. Okay, it's working fine. Another one, this is a train. So I hope you enjoyed this tutorial as well. Thank you very much. You are most welcome to subscribe. Bye bye.